if m and n are integers, is m to the power n an integer? Okay, analyzing the question, what it tells us is that m and n are integers, but they are not restricting the sign, so they could be either positive or they could be negative. Now the question is if m to the power n is an integer. Okay, at first glance you might think, well, isn't an integer to the power of an integer always going to be an integer? But the thing is that in data sufficiency there is never the case in which you do not need any statement at all to solve the question. So there must be some cases in which this exponent is not an integer, okay? And since they can be positive or negative, the only possible case is in which n is negative, because when you have a negative exponent, for example 3 to the power negative 2, the negative exponent inverts the number, so that would be 1 over 3 squared, which is 1 over 9, and this is not an integer, even though 3 and negative 2 are integers. Okay, so this is actually what I'm trying to look for, if n is negative. This is the real question. Okay, so statement 1 says n to the power m is not an integer. So what statement 1 is saying that is that m is negative, but I don't need to know anything about m, I just need to know about n. Okay, so it's not going to be sufficient, right? You can put some examples. For example, if n is 2 and you have a negative 2, well, this is not an integer, definitely, because it's 1 over 4. And if I try these numbers in the question, that would be negative 2 squared. And this is an integer because this is 4. It answers yes. And if I try another number, for example, negative 2 to the power negative 2, this is again 1 over 4 because it's going to be positive. The exponent is even. And in the question, if I replace it, I will have negative 2 to the power negative 2, and this would be 1 over 4. The answer is no. Okay, so it's not sufficient. Statement 2 says n to the power n is an integer. Okay, n to the power n is an integer. You could think, well, okay, so n has to be positive, right? But is there a negative number that makes this statement true? For example, negative 3 to the power negative 3. This is going to be 1 over negative 27. So I cannot try that because it makes the statement false, right? But I can try negative 1 to the power negative 1. Now this number is negative 1. And it makes the statement true because it is an integer. But n being negative 1 in the question answers no. And then you could try another number, for example 2 squared, which is 4, and it answers yes, okay, to the question. So you have two answers, not sufficient. Now we need to see them together. Now, since negative 1 was the only value in statement 2 that answered no, can I still use it in statement 1? So negative 1 to any power, for example, I don't know, 2, 3, negative 5. This is always going to be either 1 or negative 1, right? Depending if it's even or if it's odd. But the statement says that it is not going to be an integer. But since it is an integer, the result, it means that I cannot use negative 1. Okay. So since negative 1 is eliminated from my answer choices, the other answers for n are positive. and they all answer yes. Okay, so statement 1 and 2 alone together are sufficient. That would be letter C.